Okay, Algebra 2, let's jump into section 4.2. And we're still doing the same thing in 4.2 that we were doing in 4.1. We're going to be graphing quadratic functions, which are parabolas. The only difference here is that we're going to be graphing them out of standard form, whereas in section 4.1, we were graphing them out as vertex form. So it's really the same process, but with one little extra step right here that we have to do. The vertex is really easy to read out of vertex form, but in standard form, we have to do a little bit of digging for it. So this is just a reminder that right here, guys, this is what the equation of standard form of a quadratic function looks like. F of x is equal to ax squared plus bx plus c, and there's two little equations that we're going to learn that go along with this, although they're really the same thing. The axis of symmetry is the line that's going to go right down the middle of your parabola. So if we think about what a parabola looks like if it opens up, the axis of symmetry might be that line right there. And what's important to realize is that that axis of symmetry always has to pass through your vertex right there. So here's what we need to know, guys, and we need to make sure we get this written down. The equation for the axis of symmetry in any parabola is going to be x is equal to, and now using this value right here, b, the coefficient of x, and this value right here, a, the coefficient of x squared, our formula for the axis of symmetry is x equals the opposite of b over 2a. So let's go ahead and box that up. So that's a little phrase you guys want to have memorized here pretty quick. The opposite of b over 2a is how you get your axis of symmetry. The reason for that can be explained a couple of different ways, but I would imagine most of you guys aren't too concerned about it. If you're dying to know, tell me in class and we'll work it out. Now, once you find the axis of symmetry, when it comes time to locate the actual vertex, that's going to be an ordered pair. And this axis of symmetry, this x value right here, is the x-coordinate of your vertex. So that negative b over 2a is your x-coordinate. Now, once you've found the x-coordinate, all you're going to do is take that number there and plug it right back into this function here and here to figure out the y-coordinate. So the way we would write that for the y-coordinate is that you're going to evaluate the function f at the number that you just came up with in the first part. So it's f of negative b over 2a. Honestly, I'm expecting that that's probably going to confuse you guys a little bit, and that doesn't surprise me. So let's focus on this fact right here. That's how you get the x-coordinate of your vertex, and then you just plug it back into the function to figure out the y-coordinate. Okay, that's enough theory right here. Let's dive in and let's see this one in action. So we're going to do a few examples right here. It looks like I've got 3 for you guys, where we're going to graph and label a quadratic function that was written currently in standard form. So here's our first one. F of x is equal to the opposite of x squared minus 6x minus 4. Now, knowing what you guys know from 4.1, I'm hoping you can tell me a few things. First of all, your a value here is the coefficient of x squared, which is negative 1. And that tells us 2 important things. First of all, it tells us that our parabola opens downward, since a is negative. Second of all, in terms of the width of this parabola, we are dealing with a normal parabola here, not wide and not skinny, because the absolute value of a is equal to 1. So those are 2 important things. And normally now in 4.1, I would ask you guys where the vertex is located, but we don't know that from here. So here's the new thing that we just learned. The x-coordinate of our vertex, or the axis of symmetry, is given to us by this formula right here. X is equal to the opposite of b over 2a. And that's going to change those numbers on each problem here. So let's take a look. B is the coefficient of your x term. So in this problem, b is equal to negative 6. And since we want the opposite of b, that now becomes a positive 6 up in the numerator. Down in the denominator, this is 2 times your a value, which came from right here, of negative 1. So that becomes a 6 over negative 2, and because this one works out nicely here, you're welcome everybody, 6 divided by negative 2 is negative 3. That number right there is the equation of your axis of symmetry, and it also is going to tell us the x-coordinate of the vertex. So let me go ahead and label here that our AOS, axis of symmetry, is going to be the line x equals, and then this number right here, negative 3. Now, hopefully you guys remember this from chapter 2. Any line that's x equals a constant is a vertical line, and this number here is your x-intercept at -3. So I'll go ahead and I will draw this little dashed vertical line right here, guys, at x equals -3. That's our axis of symmetry. The next thing we would need to do is make ourselves a quick little table right here, and just like we were doing in 4.1, excuse me, we're going to do this with 5 values. And this value that we came up with here, this -3, we think that's the x-coordinate of our vertex. So I'm going to put that right in the middle here, okay, and I'll build some other x values around that. And hopefully this is going to work out the way that we wanted it to. Now, to find the y-coordinate of your vertex, we're going to take this -3 and plug it back into the original function right here. Now, because I don't have a TI-84 on my iPad where I'm recording this, I'm going to do this by hand. But I would expect you guys to probably go to the table feature in your TI-84 and let it fill in the table for you. So let's see what we got here, guys, if we can wing this. -3 squared is 9, but the opposite of that is -9. That's a plus 18. -9 plus 18 is 9, and 9 minus 4 is going to get us 5. So -3, 5 right here, that is where our vertex is going to be located. Now, picking an x value less than that, I'm going to go -2, -1. Those are actually greater. I'm sorry. Let me undo that there, everybody. I'll put a -4 here and a -5 there, and then a -2, -1. And as quickly as I can, let me run through this. But this is definitely harder to do than vertex form when you're doing it by hand. Okay, -5 squared. We end up with a -25 and then a plus 30. So we're at 5. 5 minus 4 is 1. So I've got the point -5, +1 right there. Plugging in a -4, that first term becomes -16, plus 24 is 8, and 8 minus 4 is 4. So -4, +4 gets us a point here. Plugging in that -2, let's see, that is going to get us 4 again. So we have a solution at 2, 4. There's a fourth point, and plugging in that -1 is going to get us 1 here. So -1, 1 gets us a fifth point right there. And if we think about all the things that we thought we knew this parabola was going to open down. It looks like it does. And we thought we knew it was going to be a normal width. I think it is as well. So now I'm ready to go ahead and connect those dots with, as much as I can, a nice smooth curve right here. You don't want this to be like a big sloppy V right there. And there you go, guys. That's a pretty decent graph of what our parabola looks like. The only thing I should have labeled here is that our vertex is located right over here at the point -3, 5. Now, we've talked about this before. Let's talk about it again. Since this parabola opens downward, we know that this vertex right there should be the maximum value of all the y values in this function. And as we look at all these y values in this column right here, sure enough, that 5 looks like it's the biggest that we're going to see. And furthermore, with our vertex in the middle, we see symmetry around that vertex. 4 and 4 for these two y values, and then 1 and 1 for these two y values. So it's really a really similar process to what we did back in 4.1. We just had to do this work up here in order to find the vertex. Okay, but we've got our axis of symmetry right there in the middle at the line x equals -3, and we've got our vertex located right here at the point -3, 5. So when the directions said graph and label each quadratic function, this one's in pretty good shape. All right, let's knock out a couple more here, guys. Okay, g of x is equal to 3x squared minus 12x plus 6. Here's what I'm hoping you guys can tell me. First of all, this thing opens in what direction? Since a is positive, it opens upward. Next question, is it wide or skinny or normal? This 3 right here is stretching our graph vertically. It's making it taller, which gives it the appearance of being skinny. So that's an important one to know as well. And now we've got to try to figure out where our vertex is located. So here we go. X is equal to, once again, the opposite of b over 2a. So let's see what we can do here. Our b value is negative 12, so the opposite of b is positive 12. And down in the denominator, we've got 2 times an a value of 3. So that's going to be a 12 over 6, which divides out nicely to equal 2. Okay, so we know already, guys, that the equation of our axis of symmetry now is the line x equals 2. So here's the x-intercept of that line, and I'll go ahead and I will draw a dashed vertical line passing through that spot. And we know that our parabola has a vertex somewhere on that point right there. We just got to figure out where. So there's the first thing we needed. And now let's go ahead and set up our table, everybody. Here's an x column and here's a y column. This x value of 2 we just came up with is going to go in the middle of that table. Less than 2, I'm going to put a 1 and then a 0. Greater than 2, I'm going to put a 3 and a 4. So the order in which you do this makes no difference, but we're going to take those 5x values and plug them into the original function. But again, I would think you guys would probably use your table in order to do that for you. I'm going to start with the 2, which was our vertex right here, guys. Let's see, the 2 squared is 4. 4 times 3 is 12. 12 minus a 24 is a negative 12, and negative 12 plus 6 is a negative 6. So I think I've got my vertex here at 2, negative 6. Okay, this point right over there. Let's plug in the rest of them as quickly as we can. Putting in a 1 now, that's going to be a 3 minus 12, negative 9, plus 6 is negative 3, so 1, negative 3. Got it? Plugging in a 0, this is nice and easy. 0 minus 0 plus 6 is 6. So we've got the ordered pair 0, 6. That 3, I'm pretty confident, is going to give me negative 3, and that 4 should give us a 6 as well. So that gets us a solution right here at 3, negative 3, and another one at the point 4, 6. Okay, look at what we know here, what we thought we know. Does this parabola open up? It looks like it. Is it skinnier than normal? Yeah, it looks like that as well. So we're going to try our best to draw our parabola passing through those five points. Although when you have a skinny one like this, it's kind of tough to draw it right. But there you go, guys. It looks something like that. So we should label our axis of symmetry at the line x equals 2. And we found our vertex right here at the point 2, negative 6. So I'll label that as well. And once more, guys, notice the symmetry of the table. Negative 3 and negative 3, 6 and 6. If we're doing this right and consistently, we should see that same thing happen in every table that we make. Okay, so that's 2 so far. Let's dive into a third one, and this one has just a little bit of a wrinkle to it. H of x is equal to negative 1/5 x squared plus 2x plus 1. Here's what I'm hoping you guys know already. It opens in what direction? Because of that negative sign right there, we know that this thing is going to open downward. Gotcha. And then, is it wide, skinny, or normal? Our a value here is negative 1/5. The absolute value of that is positive 1/5. That's less than 1, so that makes our parabola shorter. It gets compressed vertically towards the middle, which gives it the appearance of being wider than normal. Okay, so let's get to it then. Location of our axis of symmetry. X is equal to the opposite of b over 2a, and I don't think you guys are going to like what happens next. Let's take a look. B is 2, so the opposite of that number is going to be negative 2. Down on the bottom, we're multiplying a 2 times your a value right here of negative 1/5. And I would imagine most of you guys would probably want to use your calculator here and use the stacked fraction feature. And again, unfortunately, I can't show you that on this video because I don't have a TI-84, but I'm going to ask you guys to trust me that what happens here, the 2's cancel out, the negatives cancel out, and you end up with a 1/5 on the bottom of a fraction, which actually becomes a 5. So that spot right there is where our axis of symmetry is located. It's the line x equals 5. So let me put a quick dot right there and a dashed vertical line right there, and there's our axis of symmetry. Now it's table time. X and y And again, we're going to put 5 values in here, although actually I might have to cheat on this one, and I'll show you why. My 5 is going to go in the middle here, and let's see what happens when we plug that in. Right here, 5 squared is 25. 1/5 of 25 is 5, and the opposite of that is negative 5. The 5 times 2 in the middle here is going to get me 10. So I'm at negative 5 plus 10, which is 5, plus 1 gets us 6 for our y-coordinate of our vertex there. So the ordered pair 5, 6, yep, we are right about here. So I believe that's my vertex. Now, since this parabola opened downward, this vertex right here should be the highest point on the graph, and all the other y values we come up with should be less than that. We'll find out. Now, I want to warn you guys, what I've been doing so far when I go to fill in the table would be above this vertex, putting in an x value that's 1 less than my vertex, and then 1 less than that. But you're not going to like that on this problem right here. Because of that fraction out in front, you're going to end up with some really ugly fractions or decimals. So my recommendation for you guys would not be to jump just by 1, but rather to jump backwards by 5 units, because that's your denominator right here. 5 units less than 5 is going to be 0. And 5 units more than 5 is going to be 10. And if we've done this right, we should end up with some answers that are not all that bad, and we shouldn't have to deal with fractions. Let's check it. If we plug in this 0 right here, let's see what happens. 0 squared is 0, times negative 1/5 is 0 as well. 2 times 0 is 0, so 0 plus 0 is 0, plus 1, we end up with a nice whole number of 1. And we get a solution right there at the point 0, 1. The same thing should happen when we plug in 10, but I don't want to assume. So let's try all this again, plugging a 10 in for x. 10 squared is 100. 1/5 of 100 is 20, and the opposite of that makes negative 20. Plus, 2 times 10 is 20. That's 0, and 0 plus 1 is 1. So we get a solution here at 10, 1. Now, with only 3 dots, this still does what we think it should do. It looks like it's opening downward, and it looks wider than normal. Things get weird, though, when I go to jump another 5 units backwards and I try to put negative 5 here. I don't know if this is going to fit on my graph or not. Let's find out. Negative 5, I'll tell you what, let me erase all of this right here, and let's get to it. Negative 5 squared is positive 25. 1/5 of that is 5, and the opposite of that is negative 5. Then, plus 2 times negative 5, that's minus 10, and then plus 1. So that's a negative 15 plus 1, which is negative 14. Now, guys, this point is right. The only problem is when I go to plot it, negative 5, negative 14 would be way the heck down here somewhere, and I don't really know that it would show up on my graph. And the same thing would happen when I went to put 15 over here. That's way too far to the right, and we're going to get that same y-coordinate of negative 14. So with these fractional coefficients right here, like a 1/5, we kind of have to take that on faith. But it does what we thought it should do, guys. It's a parabola opening downward, and it definitely looks wider than a normal parabola would. Okay, and I ran out of room right there, so that's as much as I'm going to draw. So I'll label my axis of symmetry here at the line x equals 5, and I'll label our vertex right here at the ordered pair 5, 6. Okay, so that, everybody, is kind of how we graph quadratic functions that are written in standard form. You now have to do all this work at the beginning right here just to figure out the x-coordinate of your vertex, which is also the axis of symmetry. But once you get that, that's where you put that number right in the middle of your table. So this was our vertex right here, and then yet again you've got the symmetry here, the 1 and the 1 in those y-coordinates, and the negative 14 and the negative 14 in those two y-coordinates. So that's most of what we're trying to do here in section 4.2. I did want to take just a second and do one or two of these problems with you here because I think they're fun. We have a quadratic function that is written right now in standard form. They want us to write it in vertex form. Well, if you remember what vertex form looks like, everybody, it is going to be f of x is equal to your a value, and then x minus h quantity squared, and a plus k. And the vertex is the ordered pair here, h comma k. Meaning, if we knew the value of a and the value of h and the value of k, we could write our equation directly into vertex form. Well, that's what we're going to try to find out here. Now, the good news is we already know what a is. A is the coefficient of x squared, which in this problem is 1. So I'll go ahead and box that up. But now I can kind of work backwards and find the vertex here just by locating it the same way we did in the last three examples. X is equal to the opposite of b over 2a. So in this problem, b is 12. The opposite of that is negative 12. And on the bottom, 2 times an a value of 1. Okay, that becomes a negative 12 over 2, which equals negative 6. And right there, guys, you just found your h value. Okay, negative 6 is equal to h. All right, and to figure out now the next part of that, we're going to evaluate f, the original function, at this value we just came up with, negative 6. So let's see what that looks like. Negative 6 squared is a positive 36. Then 12 times negative 6 is a negative 72 and plus 11. Okay, 36 minus 72 is negative 36. Adding 11 to that, we're going to be at a negative 25. That right there, you guys, is your k value. So now we know the value of a, the value of h, and the value of k. So now we're ready to put it all together now in vertex form. F of x is equal to, and I'm following this pattern right here, guys, our a value is 1, and you don't really have to write 1 out there, but in parentheses, it's going to be x minus this h value right here. Minus negative 6 is plus 6. Close it and square it. So there's your x minus h quantity squared, and then plus k, we'd be adding negative 25 at the end, which is the same thing as just doing a minus 25. Okay, so that's what this same original function looks like here if we were just going to put it in vertex form. Now to prove that to you guys real quick, let's see, I'm just going to go to Desmos right here. Let's just type this in, Desmos, there you go, Desmos calculator. And I'm going to graph the original function that was given to us in this problem. This looks a little different than your TI-84, but you could do it the exact same way. So we had for this problem, y is equal to x squared, and then I forgot here, guys, it was a plus 12x plus 11. So where am I here? Plus 12x, nope, I missed something right there. Plus 12x and plus 11. One more one there, Mr. Fontana. Okay, there we go. And that is what our parabola looks like, kind of like that. Okay, now, what we're going to do is type in now what we think our answer is, which should be the same function, but now written in vertex form. So my final answer we came up with was right here, x plus 6 quantity squared minus 25. So in parentheses, x minus 6, close the parentheses, square it, and then a minus 25. Let's see if I had that one right there. I lied. I'm sorry. That was an x plus 6, not an x minus 6. I typed that in wrong. So let me go back and fix that. And now I think we're going to be happier here. Okay, if you notice there, guys, when I hit enter, this doesn't look like two different functions. It looks like the same function here. And that's because these are two different equations of the exact same parabola. That's why they end up looking like the same graph, because they are the same graph. They're the same function. It's just that the original one was written here in, here we go, standard form, and this one now was written in vertex form. But that's why this one works out that way. And I had another example with you for you guys to do with you right here, but I think I'm going to let you work on that one on your own, everybody, okay? All right, so that's a wrap, I think, on 4.2. You guys should be able to knock out most of that homework. Give it a try, and let me know when you have questions. Good luck.